problem is related to problem 3 from homework set 3. Now we're given a 50 kilogram object initially moving south or down. We can give this 50 kilograms, 50 kg, 30 meters per second. Those are the first things we're just immediately given. We see a force acts on it for 3 seconds, after which it moves northeast, or northeast is this direction, at 30 meters per second. And northeast we're going to assume is exactly at 45 degrees. And so it asks, what is the magnitude and direction of the average force that acted on the object over the 3-second interval? Well, we know that V final equals V initial plus A T, where our V final and our V initial can both be expressed in component vector form, or V initial, our speed pointing down. It has no x component, and it points in the negative downward y direction. Our V final, we see, well, it creates a triangle. And so we have to do a little bit of trig to figure out our x and y components. And we can use SOHCAHTOA. Sine equals sine of, well, here, let's say 45 in this problem. Sine of 45 equals opposite over 30, and doing this for cosine as well, where we get adjacent over 30, and our opposite is going to be here, our adjacent is here. That tells us our x and y components, which we find to be 30 cosine 45, 30 sine 45. And we're just going to leave it in that form. If we were to evaluate this in a calculator, we would have to round a decimal, and it's going to give us rounding error, something we very much like to avoid. Now we see, well, we know t is just 3 seconds, a scalar. Acceleration is, well, some unknown vector. Sorry, not plus ax comma ay meters per second squared. We can express all these variables as vectors. And if you were so inclined, you could actually plug each of these vectors into this equation. And that process is the same. It just sort of skips a few more steps as just evaluating this equation in the x coordinate direction and in the y direction, right? We can just sort of do them both at the same time by using these vectors, right? So you could say 30 cosine 45, and here let's just say we're looking at the x direction first, equals v initial 0 plus ax times 3. And we find our ax is 10 cosine 45 just by dividing 3 on both sides. And so we found our ax. We can do the same thing for ay, 30 sine 45, our final y, equals initial y, which is negative 30, plus ay times 3. And so we end up finding that ay equals 10 sine 45 plus 10. Both of these are just real numbers, and we can put them into a calculator. And that tells us that our a is going to be 7.07, 17.07. And that tells us the acceleration force that we are feeling, right? This is the acceleration the object is under. And, well, we remember something we learned about recently, Newton's second law of motion. Whoops. We know F equals mass times acceleration. And so when we're looking at the force, that's what we're trying to find for our final answer, right? We're looking for the magnitude and direction of the average force. Well, in the hint, you see F equals ma, and we found our A. We're actually going to want to find the magnitude of A, and use that as the number in the equation, right? And that's just the square root of each component squared summed up, right? And that tells us that A equals 18.5 meters per second squared. Mass was 15 kilograms. And so we can find the average force. And of course, this is just the magnitude of the average force, but it does get us the magnitude. We find F to be 277 newtons. Now, how do we figure out the direction? Well, when we look back at our problem, we had an acceleration, and we actually found an acceleration vector. And we know that acceleration and force will always point in the same direction, right? When we look at this equation, we can actually write it with vector notation on top, where in reality, force and acceleration point always in the same direction. They're just different magnitudes. Multiplying by m, multiplying by a scalar, just changes the magnitude of a to become this new vector f. And so if we find the direction that a points in, we've actually found the direction of the force. So remember that the equation for finding theta is tangent theta equals opposite over adjacent. And if we want to draw our triangle, we have an x of 7.07, y of 17.07, and we're just trying to find this angle theta. And so our opposite, you can write this out as here, theta equals tangent inverse of our opposite 17.07, that, divided by 7.07. And this gives us a theta of 67.5 degrees. So we know that the reactive force, or the average force, points 67.5 degrees above the positive x-axis, the magnitude of 277 newtons. And that is our final answer.